On June 18, 2026, at 02:14 hours local time, a railway bridge spanning the North Crimean Canal near the town of Rozdolne, occupied Crimea, was 38 minutes from being hit. This was not a civilian crossing, it was a military artery. Every week, dozens of freight trains rolled across it carrying ammunition, fuel, armored vehicles, and personnel into the Crimean interior, feeding Russian garrison forces along the Kherson axis, supplying air defense units at Saki and Belbek, keeping the logistics chain alive that sustained Russia's entire southern flank. Conservative estimates put the volume at over 35,000 tons of military cargo per month through this single choke point. The Russian garrison commander responsible for the Rozdolne corridor had reinforced the bridge's local air defense with Tor M2 systems and increased patrol frequency along the canal bank 2 weeks earlier. He believed the crossing was defended. He believed the geometry of Crimea, its distance from Ukrainian-controlled territory, its layered radar coverage, made a precision strike operationally implausible. He had 38 minutes to find out he was wrong. 41 modified UJ-26 Beaver drones, Ukrainian-built fixed-wing one-way attack aircraft, lifted off from concealed forward launch positions near Kherson Oblast at 01:36 hours, flying in 3 sequenced waves, each separated by a 12-minute interval. They skimmed at altitudes between 50 and 80 meters above the steppe, precisely low enough to stay beneath the acquisition floor of the Tor M2's passive radar in search mode. These were not random drones sent in a general direction. Each wave had a specific assignment. The first wave carried precision warheads targeting the bridge deck itself. The second carried delayed fuse munitions designed to detonate during repair operations. The third held in a loiter orbit, waiting. What followed unfolded across not one night, but 3 separate strikes, each building on the damage of the last, each time to hit exactly when Russia thought it had recovered. The Rozdolne bridge was heading into something Russia had not fully calculated, a coordinated campaign of sequential destruction, not a single hit-and-hope strike. Those 41 aircraft represented the most operationally sophisticated railway interdiction attempt Ukraine had mounted in Crimea since the war began. To understand why this target mattered, you have to understand Crimea's geography as a logistics problem. The peninsula has 3 primary supply routes from mainland Russia. The Kerch Bridge Road and rail crossing is the most famous, already struck twice, forcing Russia into expensive defensive upgrades and traffic throttling. The maritime route through the Kerch Strait relies on ferry and coastal vessel movement, which Ukrainian Magura Vi-5 surface drones have made progressively more dangerous. That leaves the overland rail network through the Perekop Isthmus, the narrow land corridor connecting Crimea to mainland-occupied Ukraine, as the primary surviving high-volume supply route. The Rozdolne Bridge sits directly on the Kerch-Dzhankoi rail line, which is the spine of that overland network. Traffic moving south through Armyansk and Dzhankoi passes through Rozdolne before fanning out towards Simferopol, Sevastopol, and the western coastal garrisons. Damage this crossing, and you don't merely inconvenience a logistics schedule. You force Russia to reroute everything through road transport, which moves at a fraction of the tonnage and is far more exposed to interdiction. What's most surprising about this target is not the bridge itself. It's how long Russia assumed it was too far from the front line to require serious hardening. For months, Ukrainian OSINT analysts and signals intelligence teams had been tracking train compositions moving through Rozdolne, identifying cargo manifests by the configuration of flat cars, the silhouettes of covered vehicles, the frequency of fuel tanker blocks in each consist. The picture that emerged was damning. Rozdolne was not just a transit point. It was a throughput node with consistent, predictable scheduling. The same train configurations were moving at the same hours, under the same minimal air defense coverage, week after week. One detail that stuck with the planning team: Russian rail dispatch records, partially recoverable through signals intercept, showed that priority military cargo trains were scheduled to cross Rozdolne 3 times in a 48-hour window beginning on June 18th. The strike was not random. It was timed to the Russian logistics calendar itself. I went through the open-source reconstruction of this planning phase, the telegram posts from Ukrainian drone units, the satellite imagery timestamps, the signals patterns, and one detail kept standing out. The Ukrainians did not plan this as a bridge strike. They planned it as a logistics collapse event, sequenced deliberately to maximize the disruption window. Here is the part that doesn't make sense on the surface. The UJ-26 Beaver is not conventionally regarded as a precision bridge strike weapon. It's a fixed-wing loitering munition with a payload in the 60 to 90 kilogram range. Powerful enough to destroy a soft target or light vehicle, but not what you'd classically assign to a reinforced concrete railway bridge. So how did Ukrainian planners intend to actually bring it down? The answer is in the sequencing. A single UJ-26 cannot collapse a railway bridge span. But 3 UJ-26 strikes concentrated on the same structural section, delivered at intervals with each hit targeting the already stressed support geometry, can initiate a progressive structural failure that gravity and load stress will finish. The Ukrainians had studied failure patterns from prior strikes on Russian logistics infrastructure, including their own previous attempts against canal and road bridges in the south. They had learned that precision matters less than sequencing. The UJ-26 Beaver, full designation UJ-26, Ukrainian-manufactured, turbofan-assisted fixed-wing kamikaze, has a published operational range of over 800 kilometers on standard fuel load, though combat variants with warhead packages typically fly effective missions in the 400 to 600 kilometer envelope. It cruises at approximately 140 kilometers per hour, which makes it slow by aircraft standards, but nearly invisible to radar systems optimized for faster threats. Its navigation package combines inertial guidance with a terminal optical or IR seeker, giving it the ability to lock onto a structural feature, a bridge pylon, a deck seam, a support bearing, in the final approach phase rather than flying a pre-programmed GPS coordinate alone. For this operation, the Beaver variants used carried modified warhead packages with a delayed detonation option, allowing the munition to penetrate partially into structural material before triggering. This matters enormously for bridge strikes, where surface detonation disperses blast energy into the air, rather than into the load-bearing components. The ECM environment along the approach corridor was the primary tactical challenge. Russian electronic warfare systems deployed in northern Crimea, including ground-based GPS jamming arrays near Armyansk, had been increasingly effective at degrading Ukrainian fixed-wing drone navigation in the Perekop corridor. Earlier Ukrainian strikes in the region had shown GPS drift, causing terminal targeting errors of up to 40 meters on approaches from the north. The Balista unit, the MiddleStrike special operations drone element assigned to this mission, solved this through route geometry. Rather than approaching from the north along the most direct axis, the first wave flew south along the western Crimean coastal corridor, staying below radar acquisition altitude over the low terrain west of Rozdolne, then executing a 90-degree eastward turn for the final 12-kilometer terminal approach. This routing kept the drones in radar shadow from the primary Tor M2 acquisition antenna until they were too close for an effective intercept solution. The planning phase had consumed 6 weeks. Satellite imagery from commercial providers, corroborated by signals patterns and agent-sourced bridge maintenance schedules, gave the team a precise picture of the target. They knew which span was most structurally critical, the third span from the southern bank, where the bridge crossed the deepest section of the canal and where a collapse section would be most difficult to bypass with emergency bridging equipment. They knew when the Tor M2 crews rotated. They knew the patrol boat schedule on the canal. They knew that on the night of June 18th, a priority military freight train was scheduled to cross Rozdolne at approximately 03:20 hours, and that if the bridge were struck before that train cleared, the locomotive and cargo would be stranded on the northern approach section. The launch window was chosen for 01:36 hours for 3 specific reasons. It placed the first wave at target at approximately 02:14 hours, ahead of the scheduled train crossing during the lowest activity period of the Tor M2 crew cycle, and under partial cloud cover that degraded Russian optical observation posts along the canal bank. Wave 1, 16 UJ-26 Beavers, crossed the canal bank heading toward the Rozdolne Bridge at an altitude of 62 meters, then descended to 40 meters for the final 4 kilometers. The Tor M2 system's acquisition radar swept the sector but did not achieve a consistent track. The combination of low altitude, approach geometry, and the radar's own ground clutter suppression algorithms worked against it in this terrain profile. The first three impacts struck the third span's southern bearing assembly within a 40-second window. The fourth and fifth drones, carrying the delayed fuse variants, impacted the deck surface directly above the primary load beam, detonating a full 1.4 seconds after impact. Drone camera footage, subsequently released by Ukrainian Special Operations Forces Command, showed the deck surface buckling visibly after the fourth hit, a section of rail twisting upward as the underlying structural integrity failed. The bridge did not collapse in that first wave. It was damaged. The third span was effectively out of service. The rail line severed, the southbound freight train brought to a halt on the northern approach. But the main span remained partially standing. The planners had expected this. Here's the take that will probably get some pushback. The Ukrainian decision to stage this in 3 waves rather than commit everything in one strike was not just tactically sophisticated, it was strategically smarter than most Western military analysis gave it credit for at the time. The conventional doctrine for infrastructure interdiction, inherited from Cold War planning, pushes for overmatch, hitting harder than necessary to guarantee destruction on the first attempt. What Balista demonstrated is that sequential, learning strikes, each one exploiting the damage state left by the previous, can achieve the same result with fewer assets and greater adaptive precision. Russian repair crews responded within hours. By 06 hours on June 18th, a heavy crane train had arrived from Dzhankoi, and engineering personnel were on site assessing the damage. Russian state media acknowledged a technical disruption on the line without specifying cause. Military bloggers on Telegram were faster. Images of the damaged span, shot from a distance by locals, circulated within 90 minutes of the strike. The repair assessment, reconstructed later from OSINT sources, concluded that the third span's bearing assembly was repairable within 72 hours using the equipment on hand, and that the deck damage above the load beam could be bypassed with emergency track laying within 48 hours. Russian engineers began positioning equipment accordingly. Wave 2 launched on June 20th at 23:47 hours. The target this time was not the bridge, it was the crane train. 14 UJ-26 Beavers, again routed along the western coastal corridor, converged on the Rozdolne site just minutes away from where Russian repair crews had been working for 2 days. The crane vehicle, a Soviet-era EDK-300 railway crane, irreplaceable on short notice in Crimea, took a direct hit on its lifting superstructure. 2 additional drones impacted the rail staging area north of the bridge where emergency bridging sections had been offloaded. The bridge damage, already partially stabilized by Russian shoring operations, received 2 additional hits that reopened the structural failure in the third span's bearing assembly and propagated a new fracture into the second span. Put yourself in the position of the Russian engineering commander on site that night. You have spent 2 days organizing a repair operation under pressure, moved heavy equipment to a remote canal bridge in occupied Crimea, your crane is now burning, your bridging sections are destroyed, and your communications are telling you that Ukrainian drones are still in the area. What do? The Russian response was to withdraw the repair teams and request reinforcement before attempting further work. This created exactly the pause the Ukrainian planners had anticipated. Wave 3 launched on June 23rd. By this point, the bridge had been in a degraded state for 5 days. Russian rail traffic through Rozdolne had ceased entirely. Rerouting through road transport was underway, but already creating visible congestion at the Perekop crossing points, observable in commercial satellite imagery. The third wave, 11 UJ-26 Beavers, the smallest of the 3, targeted the remaining standing span sections with a simple objective: ensure that no emergency repair could restore even partial function within a time frame meaningful to Russian logistics planning. The third span, already critically damaged, collapsed into the North Crimean Canal under concentrated hits on its compromised northern support column. The second span, cracked from Wave 2, failed under the additional stress. By 04:30 hours on June 23rd, the Kerch Dzhankoi rail line at Rozdolne was physically interrupted, not disrupted, not degraded, but interrupted, by approximately 60 meters of collapsed bridge infrastructure lying in the canal. Battle damage assessment from satellite imagery confirmed the structural failure within 18 hours of the final strike. Rail traffic on the Kerch-Dzhankoi line remained suspended. The logistical consequences were immediate and measurable. Russian resupply to the western Crimean garrisons shifted entirely to road transport, tripling the vehicle movement requirements and creating identifiable bottlenecks that Ukrainian HIMARS and strike drone assets could, and would, begin targeting in the following weeks. What this operation tells us about where the drone war stands in mid-2026 is this. Ukraine has moved past single-strike tactical harassment and into deliberate operational interdiction. The Rozdolne campaign was not a lucky hit. It was a 6-week planned, 3-phase, sequentially adaptive operation that demonstrated the ability to learn from each strike in near real time, adjust targeting based on enemy response, and deny recovery as effectively as it denied function in the first place. Russia will rebuild. Emergency bridging can restore partial function in weeks if the right equipment reaches the site. But the Rozdolne operation has forced Russia to commit significant engineering and air defense assets to protecting logistics infrastructure it previously considered safely distant from the front. Every resource assigned to protecting a bridge is a resource not defending a frontline position. Will operations like this become the defining pattern of the next phase of the war? Comment below, yes or no. The evidence from the last 6 months suggests the answer is already written in the rubble of the North Crimean Canal crossing. Every railway bridge, every repair yard, every logistics node in occupied Crimea is now inside the operational envelope of Ukrainian strike drones. Russia knows this. The question is not whether Ukraine can reach these targets. The question is whether Russia can protect all of them at once. And the answer is becoming clearer with every collapsed span.